Greetings, M squared here, and today we're going to talk about domain and range. So just in case you don't remember a few of these things, we're going to go over it real quick. So a coordinate plane is what this little guy is called. It's a little grid. We have 4 quadrants. We usually use Roman numerals when we label our quadrants. The first quadrant is in the top right. It's the one where X and Y are both positive. This horizontal axis is the X-axis. This is the Y-axis. That point right there in the middle is 0, 0, and it's the origin. And an ordered pair is any point on this grid. So these are ordered pairs. They're also sometimes called coordinates or points. So let's see if you remember how to graph these points. 4, 3. So remember, the X value tells you to go left or right, depending on if it's negative. And then the Y value tells you to go up, down. So with that in mind, 4, 3 would be 1, 2, 3, 4, because we start at the origin, 1, 2, 3, and that would be our point 4, 3 right there. Negative 2, negative 1 is to the left, 1 down. 0, negative 5, that means 0 left or right, and then down 5. And just in case you forgot that you can graph decimals on these grids, I'm going to go over 1 on the x-axis 3.5, and then I'm going to go down 2.5, so it's like right there in the middle of the box instead of on one of the lines where they meet. Okay, so throughout the chapter we're going to need to know some of that. We need to know about x. X goes left and right, y goes up and down. So our main goal today is to talk about domain and range. But first I want to make sure you know what a relation is. A relation is just a set of ordered pairs or a set of points. So right here, that's a set of ordered points. So we'll just use that one. And you need to know how to find the domain and the range of a relation or a set of points. So first we're going to talk about domain. Domain is all the possible x values. So when it's just a bunch of points listed, because it can also be a graph, but when it's just a bunch of points listed, it's just wants a list of all the x's. And we usually use braces, and then we usually go from smallest to largest. So when I look at the x's, I'm going to circle all the x's. So when I look at those x's, the smallest one is 2, negative 2. The next one is 0, then 3.5, and then 4. So those are all my possible x values in this set of ordered pairs or this relation. So that is considered my domain. Again, commas, smallest to largest, and then use the braces. Now the range is the y values. So I go back up there, and I'm just looking, I'll just put a little line right there. I'm looking for my y values. So I use the same braces, and I, again, go from smallest to largest. So my smallest y looks like negative 5, then negative 2.5, then negative 1, and then 3. So that would be considered my range. So your job is to be able to find the domain and range, whether it's a set of points, a table, or a graph. So we're going to do all 3 of those right now. Sometimes it's helpful to actually make a line so that you know that domain goes left and right and that range goes up and down. It's important to know that. So if I look at a graph like this, I notice that it's not just a set of individual points, but it's like an infinite number of points that is along this curve. Domain, I'm only interested in left and right. So my domain would be from this point right here, negative 3, to this point right here, which is 1. And domain is always x, so I'm going to use x variable. But because it's not just a set of points, I don't use the commas, because I don't want to say 0.5, 0.6, 0.65, 0.67. There's just too many. There's an infinite number. So I want to say that it's all the numbers between negative 3 and 1. But this circle right here, I don't know if you remember what the difference is between a closed and open circle. An open circle means that that number right there isn't included. Now, that coordinate is negative 3, 0. Those coordinates. And so when you have negative 3, 0, the x and those y's, it doesn't actually go to 0, it doesn't actually go to negative 3, but it goes right up to it. So I know that I have to put a less than sign there because I know that that's not included. So in a closed circle, I use less than or equal to, greater than or equal to, but in an open circle, I would just use a less than or greater than sign. On the other end, though, it is a closed circle. So I know that that 1 is included. So that's why I put less than or equal to 1, because the 1 is equal. And this one just says x is greater than -3. So it can't equal -3. So that would be my domain on my graph. My range would be lowest to highest. So I'm going to go from here to here. So notice that this is -4 and it goes up to 0. And again, 0 has a less than because it's an open circle. I use y as my variable this time because I'm dealing with range. And it goes down to -4, and that means I shouldn't have put 0 there. -4 is smaller. Let me switch that. So it's -4 to 0. My apologies. Okay, so I know that all the numbers between 0 and 4, it can include -4, but it can't include 0. So that's what all my possible y values are, anything between there. So I could do -1.27, -3, all of those are included in this right here. So now we're going to do some examples. So here it's a table, it's a set of values. So it makes it kind of easy because I see that my x's are all lined up and my y's are lined up. So my domain is going to be -1, 0, 2, 5. And my range is going to be 1, 2, 3, 7. So I just remember domain are possible x values, range possible y values. So my domain again is -5, -2, 0, 1, because I'm just looking for the x values. And my range looks like it's -2, 0, 4, and 8, because 4 comes between 0 and 8, so that's why I switched that order. Okay, domain and range, possible x values, possible y values. Now here it gets a little bit trickier, and the print, this didn't come out exactly correct, so that's 4. So this would be 2 and 4. My y-axis didn't show up, so you can't see what those are, so I'm going to write them there for you. So what I like to do is I pick the point highest or most left, or both, if there are 2, and I'm going to write down what that is. That's a 2, 4. Then I'm going to pick my lowest point, which is 4, 0, and I'm going to pick my most right point, which is 5, 1. Once I have those, then I know that my domain is going to go this way, right? So that's between 2 and 5. So I know that my domain is 2 is less than or equal to, closed circles, x, which is less than or equal to 5. I know that the domain is all the numbers between 2 and 5. For my range, I'm going to go this way. So I'm at 0, right? And I'm at 4. That's my high and low for my range. So my range is going to be from 0, I'm going to use y this time, to 4. Because for range, I'm looking for up or down. For domain, I'm looking for left or right. Okay, let's try this one. So this time my highest point is the most left point, and my lowest point is also the most right point. So 4 looks like -1. So this makes it easy because there's simply 2 points. So on a line segment, that happens. So domain is fairly easy because I'm just going from 2 to 4, and I'm going to use x. And my range is going from -1 to 0. Okay, that's how you do the graphs. And now this is a set of ordered pairs listed. So when I have that, I look at all my x's. I look and I say -1 is the smallest, then comes 0, then 2, then 4. So that's my domain. My range looks like -3 is the smallest, then 2, then 6, then 7. Alrighty, domain. So looks like -5 is the smallest, and then 0, 10, and 12. And then my range, -2. There's 2 zeros. I don't need to write both zeros. 1 is enough. And then the y here is 3. So it's okay to ignore one of them if you have multiple. Just write one down. Okay, the last 2 examples are going to be graphs that aren't continuous. They're just sets of points. So it's just like that list that we just did, except they're not listed. So first of all, I noticed that 2 points don't have the coordinates, so I want to make sure I write those down. So this one is 0, 1, and then this one right here looks like it's 4, negative 2. Once I have all those points, then I can find my domain by just looking at the x-coordinates. So I have negative 4, negative 3, 0, 2, and 4. So negative 4, negative 3, 0, 2, and 4. That would be my domain. My range would be going up and down, and I'm looking at the y-coordinates. So I see it's negative 3, negative 2, 1, 4, and 5 going up. So sometimes you have points and they're not named, right? You don't know the coordinates. So the best way to do that is to just write the coordinates out. So this one's going to be 1, 1. This one looks like it's 2 and 1.5. This one is 2.5 and 0. This one looks like 1.5, negative 1. And this one is 3, negative 1. So we have some decimals in there, so that's okay. We're just going to write them the same way. So my domain, going from left to right, that's my x. That's my next x. So if you go from left to right, then they're already in order for you, and you don't need to worry about switching the order. And then for range, I'm going to start down, look at the y's, and go up. So for range, negative 1. There's 2 negative 1s. I don't need to write them both. I just need to write 1. Then 0, 1.5, and 1. So that is how you find the range and domain, whether it's a graph, a set of points, or a table. That is how you find the domain and range. So good luck with that. M squared, signing out.